You've likely seen videos like this depicting what the Big Bang looks like, the whole universe exploding from a singular point, forever expanding outwards. But if we know that the universe is expanding and in which direction, shouldn't we be able to trace it backwards far enough to find where the center of the universe is? The exact point of the Big Bang, the exact center of the universe. Well, there is an answer, but I warn you, you're probably not going to like it, and it is most certainly going to give you a headache. You've likely seen images from telescopes with astronomers explaining that the light that you're seeing from that image is from the beginning of the universe. This one, for example, was the first image released by the James Webb Telescope. Some of the light that you're seeing in this image is from 13.5 billion years ago. But since the universe is an estimated 13.8 billion years old, does that mean that the light from this direction of the night sky is towards the center of the universe? Well, no, but also yes? So okay, then you might ask, what direction should we point that telescope to find the center of the universe? And here's the part that you're not going to like. The answer is any direction and every direction. The universe is equally expanding in every and all directions, all at the same time, at every single point in the universe. So the name The Big Bang is probably one of the worst and most misleading names for the beginning of the universe, because there was no explosion, there was no bang, there is no center. The universe wasn't? Then it was. The only reason why we call it the Big Bang and imagine it as an explosion is because that's simply the best way for us as humans to comprehend expansion. And I'll pause, I'll give you a moment just to sort of think about that. Okay, moment's over. Now, to further understand the concept of the universe expanding everywhere all at once, we also need to talk about time, or more appropriately, the illusion of time. You might think of time as linear. Yesterday was in the past, you listening to this show right now is the present, and tomorrow, when you're happy that you subscribe to Interstellar News, is the future. But the reality of time is far more upsetting. Time is not linear. Time is fluid. For us, here on Earth, we can look out at the night sky, observe light from very distant galaxies, and determine how long it took that light to reach us from its origin by measuring what's called a redshift. And if you point a sensitive enough telescope in any direction for long enough, you will be able to observe light from the actual beginning of the universe. But the same is true if you point that same telescope in any direction, at any point in the night sky. No matter which direction that you point that telescope, if you point it there for long enough, you will see light from the beginning of the universe. Now, if you stop and think about that for a second, you might come to the conclusion that if both time and space are equally expanding out in all directions from our perspective, no matter which direction we look, you might think that the center of the universe is, well, us, right? Well, that's not true. And I know that we all probably know somebody who thinks that they're the center of the universe, but I promise you, they are not, and we are not. And here's probably the craziest and trippiest part about the universe expanding. Let's do a little thought experiment. Let's take that first James Webb photo. As stated before, some of the light in this image is 13.5 billion years old. Now, if you were somehow able to instantly transport yourself in the James Webb Telescope 6 billion light years towards the direction of that light, and you were able to take another shot of that same point in the night sky, the oldest light that you would detect would still be 13.5 billion years old. The image that you get back might look a little different than the one that we have taken here from our solar system, but the oldest light that you would detect from that point in space would still be 13.5 billion years old. And the same is true if you were to point it in any direction. Still would be 13.5 billion years old. Now, clearly, I can't explain why all this is true in less than the 5-minute limit that I have per episode here. Today was all about a mind-melting exercise in hopes that after you recover, you'll be filled with profound questions with a fiery need to answer them. The journey to understand the universe, if anything, is a humbling and ego-reducing venture. And we may never get there in our lifetimes. We may never even get there in the entire existence of our species, but we'll certainly never get closer to understanding unless we try.